Good afternoon, everybody. We are here from Indonesia. We have a paper entitled Multitemporal Analysis of and Cover Changes on Parangtritis and dunes using NDVI, NDSI, and also clay index transformation between 1972 until 2018. There are actually 4 authors here. The first author is Yuniarsita, also attend in this room, and I am Fajrun Wahidil Muharram. So there is our chief Putri Meissarah and our co-author Bernike Hendrastuti. We are from Parangtritis Geographic Science Park, a part of Geospatial Information Agency and Mapping Authority of Indonesia. So here, sand dunes of Parangtritis were the largest sand dunes in the Southeast Asia, with the top altitude about 15 meters. It was measured by Verstappen, the geologist from the Holland. Its uniqueness lies in the Barkhan form that mostly it's common in arid or semi-arid regions. Meanwhile, Indonesia is located in the humid regions. So this is the uniqueness of the sand dunes of Parangtritis because of the Barkhan height. However, now it is getting endangered in recent decades due to the degradation of the sand-covered area because of development of building and tourism sites, and also because of deforestation, and then because of land use changes for agriculture and aquaculture. So this is the location of the sand dunes of Parangtritis in the southern part of Java Island in Indonesia. It's our research area now. We have multi-temporal imageries of the Parangtritis sand dunes. We give a yellow mark here, which is now, if we ask people where is the Parangtritis sand dune, people will direct us into only this yellow square. But in our term, sand dunes is the whole area from the previous image I show you. So this, because of this massive land use changes, we have the aims of our research to map changes in sand, between sand and non-sand land cover in these Parangtritis sand dunes between 1972 until 2018. Our methods: first, we detect the land use and land cover changes using spectral transformation with supervised multispectral classification in order to discover the area amount of change based on Nielsen and Kiefer. The first, we use NDVI as our first transformation index, normalized difference vegetation index, to compare the greenness index of vegetation because we find a lot of massive plantations above there. Second, we use normalized difference sense index to identify the sense composition itself because the sense is getting fewer and fewer year by year. And then we also use clay index in order to discover the intervention of soil solum into the sand dune area because of the agricultural purposes. And then our region of interest for the classification is determined using the spectral value of the object in 1972 because we assume that in this year the sand dune was all covered by sands, no other land cover but sands. We use the data from Landsat imageries from the first Landsat 1 until the last Landsat 8 with different sensor, of course, and also different range of wavelength and also resolution to generate the NDVI, NDSI, and clay index. We mark here that the resolution, the spatial resolution of the first sensor of Landsat, which is multispectral scanner, is about 60 meters, whereas the others, the rest of the part of the Landsat is higher than the previous one. The recent spatial resolution of the Landsat about 30 meters, but we consider it's not a big deal for us because we focus more on the spectral analysis than the spatial analysis itself. And also, the first generation of the Lancet sensor didn't have shortwave infrared wavelength, so it's only used for NDVI. But since the Lancet 5 thematic mapper sensor, we can calculate or generate the NDSI and also play index because it has shortwave infrared band, both 1 and 2. Here is our transformation. The first is the NDVI. The result is the vegetation covered area has a bright tone, like this picture on the left picture, on the bottom right of the left picture, there is some bright spot. It is indicated as vegetation. So the area without vegetation has a dark tone. How about the NDSI? So the sand covered area has gray tone as it shown in the middle imagery in the figures. And also the clay index, the area that contains clay material has bright tone, and the area that doesn't contain the clay material has dark tone. The use of clay index is helpful in detecting the land use and land cover changes in the research area, as now the area is used mostly majority for farming land. The field assessment we conduct in 2020 in last year, so that several soil samples that are taken in the farming area contains more clay than sand. So this is the reason that we use clay index in this research. However, without if we have to analyze it one by one, we have difficulties in terms of in determining what is the land cover of each area. So here we use color composite in order to help us to make it more easy for us to distinguish between sand and non-sand covered area. So we use NDSI for the red band, distance index for the red band, and the vegetation index for the green bands, and the clay index for the green bands. We have this composite. It is on like the right figure. So our composite result, we can find, based on our composite result, we can find that the virgin sand dunes area has red-orange color. Actually, for the imagery from 1988, because the first two imageries doesn't have shortwave infrared, so it has slightly different color. And also the mixture of sand and vegetation is indicated as yellow. And the third, the build area as identified, is identified at class science. Thus, we can determine that the tone of the red-orange color is affected by the existence of vegetation and built-up area. The lighter tone indicates that the area is mixed between building and or vegetation, and the darker tone indicates that the sand-covered area is purer. We have each analysis result from our paper. The first is the first year 1972. So the sand covered area is shown in magenta, as it is indicated as virgin sand dunes. So almost the whole area of the sand dunes was covered by only sands. The yellow color shows a mixture of sand and vegetation, but it's more likely it's outer than the sand dunes boundary. The second year in 1982, we found that there is a yellow spot that we mark here it is indicated as vegetation plantation. So the change of the sand dunes land cover start in this year, we assume. In 1988, the sand cover area is shown in red orange as it is indicated as virgin sand dunes. The yellow color show a mixture of the sand and vegetation. Here on the right of the sand dunes, we found that the built-up area was identified in light blue, and faded orange. So here we indicate that this one and this one is a settlement area. In 1991, we found that another spot is indicated as a built-up area. So the built-up area growth in the middle part of the sand dunes itself. In 1994, there is a massive changes of the land cover in the left of the sand dune area that we identify it is vegetation because it has a light yellow color. So actually, this is a misunderstanding of the of a critical land of the authority in Indonesia. So the sand dune was classified as critical land at the time. So the government tried to recover it by plant of vegetation in the sand dunes. This one is in 1997. We find that this data is somehow a bit outlier because it seems like the previous that the sand dunes was covered by mostly sands. We cannot figure it yet why this happened about the data. And in 2000, we found that the land cover changes in sand dune is getting more massive. The blue spot in the right of the area indicated as settlement, so it becomes bigger and bigger. And also the vegetation area in the left until the middle part of the sand dune also getting bigger and bigger. Here our data in 2003, it becomes, if we can conclude the sand covered area itself is getting smaller and smaller as it indicates in the red-orange color. So the sand covered area is getting smaller and smaller the year by year in our data. In 2009, so the spot of the sand covered area is getting smaller because the vegetation distribution reach the middle part of the sand dune as well. And this is the last data of our analysis. So the sand covered area is shown in brown only in this spot, two circles in the middle, while other area of the sand dune has changed into another land use. There are many land uses in this area. Thus, based on this, in this research, we use the data from the 1972 that we assume that all the part of this sand dunes of this boundary was only sand. So we use this spot to determine our region of interest. And then we found this data, our final result, that from the 1972 until the last year of our data in 2018, we found that in the first of the year, the sand dunes composition in percent is about 97. It covers more than 400 hectares. But in 2018, the sand dunes covered area was only nearly 15%, about 61 hectares only. So we have statistic here. We predict, so actually this is our aerial imagery from UAV we captured in 2016. So the land cover of the sand dune has changed dramatically. So we conclude that the annual average sand dunes cover area degradation based on this analysis is above 7.71 hectares. So we estimate that the sand dune will be all covered by other land use in 8 years or in 2024 if the conservation effort is not conducted. So that is our conclusion of our analysis. Thank you.
Maybe start with, in fact, I've got a question. Here we are. Can you determine pattern or process from images? That was from.
Well, thank you, Duncan, for your good questions. We do our analysis like this framework. The first we use the transformation index for the image one by one, and then we mix it with the composite. We make the classification to distinguish the M and area. Is it that what you asked? I'm sorry, I cannot get it at all.
Can I ask you a simple question?
Yes, please.
I'm a bit intrigued where the clay comes from. Perhaps it's my ignorance here, but if they were sand dunes originally, what is the provenance of the clay that you then pick up in the future?
Actually, last year we conduct field analysis, field assessment of the sand dunes area. So we distribute several sample points. We take also in the agricultural land, and based on our result, we found that the soil composition in the agricultural land is mostly consists of clay more than the sand itself, because people put the clay itself from the other part into the sand dunes area.
Okay, so it's brought in artificially by the farmers, is that correct?
Yes, is it by the farmer itself? Okay. So the farmer that do it.
We can use just Landsat imagery to develop a land use map without having real terrain data for confirmation, especially in the case of vegetation cover. You able to answer or address that?
Well, we can use.
I think maybe it's saying can we rather than we can.
In particular, I think so. We can only use Landsat data to make such classification without terrain. But if we want to develop more our results, we obviously need other data such as terrain in order to discover the more phenomena of the research area itself.